Hi guys, how are you all? Good evening to everybody. Good evening. Okay guys, so welcome to the live session of Vedantu. Okay, and this is Mridul here, master teacher in Vedantu. So guys, today's session is about triangles and it's about CBSE class 9. Okay, so as we all know, the topic in CBSE class 9 is congruency of triangles and inequalities of triangles, right? So today in this session, we are going to do problems relating both these concepts, right? So we will cover these two concepts, and basically today's session will be of more about problem solving approach, right? So I'll be showing you different types of problem, and in those different types I will show you how to approach such problems. Okay, so with that and without losing any more time, let's quickly start with the first problem. Okay, ready? Okay, so the first problem is here. It says ABC is a right angle triangle. That means this angle is a right angle. Now AB is equal to AC. That means it is also an isosceles triangle. That means this length is equal to this length, right? And then it says that CD, that means this line, is a bisector of this angle. That means this angle is also equal to this angle. Now they are asking prove that AC, that means this side, plus AD, that means this much, is equal to BC, this length. Okay, so I will give you exactly 1 minute of time to think about the approach for this, and then I will be helping you to solve this. Okay, so your time starts now. In the meantime, I will write all the given things. So it's given that AB is equal to AC. That means angle B is equal to angle C, as AB is equal to AC. Okay. Let me see how many of you can solve this. Yes, do you need some hint? Okay. And try to do it, try to think about it. Okay, so what I will do is I'll give you a hint about this. So the hint is, if I have a triangle, okay, and I have an angle bisector, say this is the angle bisector. So let me say this is a triangle A, B and C, any triangle A, B and C, and AD is the bisector of this angle such that this is equal to this. In that case, the ratio of this BD by DC can be said to be equal to the ratio of the sides, that is AB by AC. Okay, that means the base, okay, on both sides of the angle bisector should be equal to the ratio of the sides of the triangle on the different sides of the angle bisector. Okay, so using this, let's see how we can solve this. Okay, so this is a hint for this. So in this case, what will happen? By angle bisector, here we can say BD by DA is equal to BC by AC. Okay. So now this, using this, we need to solve. How to do this? Okay, so now what we will do is, let me help you. So let's say this side AB and this side AC is of length A. Okay, so let's say this is of length A. So in that case, if we apply Pythagoras in triangle ABC, so in triangle ABC, if we apply Pythagoras, okay, so what will happen? We can say BC square is equal to AC square plus AB square, and it is given that AC is equal to AB and the length, let us say A, so I can say this is A square plus A square. That means BC square is equal to 2 times of A square, or in other words, BC is equal to root 2A. So I'll be using this relationship. Okay, so now if you see here, BC is root 2 times of A and AC is A, that means this will get cancelled. So I can say that this ratio is root 2, right? That means what I'm trying to say is BC is root 2 times of A, that is fine. And what will this tell us? This will tell us that BD is equal to root 2 times of DA or AD, right? Now using this, we can move ahead and try to find out the relation or the value of AC plus AD. Now since we got the value of BC, now let us see if we can find out the value of AC plus AD as the same one, right? Now what is AC plus AD? Now let us see. First of all, we know that this length AB, okay, so AC can be written as AB, it is given in the question, and AB can be broken into these two parts, that is AD plus DB, and we know that AD and BD has a relationship. This DB or BD the same thing. right? So BD can be written as root 2 times of AD. So I can write this as AD plus root 2 times of AD. So this makes it 1 plus root 2 times of AD. So now if I go to the next page, so in this now I can say that AC is equal to 1 plus root 2 times of AD. This is what we have found out here, right? AC is 1 plus root 2 times of AD. Now, so from here I can say AD is equal to AC by 1 plus root 2, right? And if I try to do rationalization here, so root 2 minus 1 by root 2 minus 1, if I do it, so I will get AD is equal to AC into root 2 minus 1 by root 2 whole square, because this is A plus B and A minus B, so A square minus B square formula, right? So AC is nothing but A root 2 minus 1, because denominator I'm going to get 1. So AD can be written as A root 2 minus 1. So now simply AC plus AD can be written as A plus A root 2 minus 1. And from here this A will get cancelled and I will ultimately have A root 2 or root 2A. Right? So root 2 times of A. And we know that root 2 times of A is also BC. So I can say this is equal to BC. Okay? So done. So we have now proved that AC plus AD is equal to BC. So guys, these types of problem, you need to know this theorem, angle bisector theorem. So if you know this angle bisector theorem, you can easily solve this particular or these types of problem. Okay, so now let us go to the next type of problem. So in this question, it is said again that we have a right angle triangle, and again this is an isosceles triangle. So here it is saying that now this AD is not angle bisector. Now it is saying this is again angle bisector, right? So AD bisects angle BAC. Okay, again this is an angle bisector, but they are asking something different. What are they asking? They are asking that to find out BC is equal to 2 times of AD. Okay, so how will we find this? Yeah, try it again. So BC is equal to 2 times of AD. Okay. And it's given that this angle is equal to this angle and this angle is given as equal to this angle. Right? So we need to find out that BC is equal to 2 times of AD. Okay. So let's see how to solve this. So given that angle B is equal to angle C and what else is given as this is a bisector. So triangle ACD and triangle ABD. Okay, so we can say that angle corresponds to this angle and this side corresponds to this side. So I can say that this triangle ACD is congruent to triangle ABD. ABD, right? Yeah. So ACD and ABD. So these two are corresponding triangles, congruent triangles. Now, so that means we can say that this is 90 degree, right? Why? Because this angle will be equal to this angle and this is a straight line. So this is 90 degree, right? What else can we prove? We can also prove now that this side or this part is equal to this part. So we can say now that therefore CD is equal to DB. Why? Because these are corresponding parts of congruent triangle, right? So that means D is the midpoint. Okay. Now we need to prove that this is equal to this, because if we can prove AD is equal to DC, and DC is nothing but half of BC. So in that case we can prove that BC is equal to 2 times of AD. So that means what I'm showing here is the approach. So the approach should be, I need to prove that AD is equal to DC. That means I need to prove that this is an isosceles triangle. Now how do I do that? That is very simple. One way is to think that see, this is a right angle triangle and this is also an isosceles triangle. That means this angle is 90 degree and this angle is equal to this angle. So that means angle C plus angle B is equal to 90 degree, and angle C is again equal to angle B. That means angle C is equal to angle B is equal to 45 degree. So this is 45 degree and this is also 45 degree, right? Similarly, this is 90 degree and this angle is equal to this angle, because this is also the bisector. So this is also 45 degree and this is also 45 degree, right? So this angle is equal to this angle is equal to 45 degree. So now you see this is 45, this is 45. So I can say this, in this triangle DC is equal to DA. Simple, right? So I can say that in triangle CDA, AD is equal to DC, right? Because this is an isosceles triangle. Now once I can say this, so from here I can easily write this equation and I can say that BC is equal to 2 times of AD. Okay? Okay, fine. So hope you understood it. So let's go to the next question, guys. So in this type of question, what is given is, you will be given a simple triangle ABC and it is said that this side AB is equal to this side AC. It is also said that this AM, that means this, is equal to MB, that means this. Okay, and it is also said that NC is equal to AN. Okay, so now they are saying to find that this triangle ABM is congruent to ACN. Okay, fine, let's see if we can solve this. So take your time, try to think about it, and then I will solve it. So let me write down what are the things that is given. So what is given is this is equal to this. So what we can say, that angle B is equal to angle C. So one condition is already there with us, right? And we have one more condition, that is this side is equal to this side. And what else is there? That AB is equal to AC, right? So in this two triangle, we already have this side equal to this side and this angle equal to this angle. We just need to prove that this side is equal to this side or this angle is equal to this angle. So say if we are able to prove, so I'm showing you what should be the approach, how should we think. So we can say that these two triangles are congruent when angles, any two angles, right, and a side is equal to the other two angles and a side of a triangle, then those two triangles are congruent. So for example, this angle is equal to this angle, this side is equal to this side. Now if we are able to show that this angle is equal to this angle, then I can say these two triangles are congruent by angle side angle congruency, right? Or if I can say that this side BM is equal to NC, then by side angle side I can say. So anything you can do. So it's better we go for this one. Okay, so try to do this. Okay, fine. So let me help you in doing this. So the approach should be very simple. So first of all, we should target this. How can we show that this angle is equal to this angle? So let's try to use what is there with us. Okay, so triangle, first of all, in triangle ABN and triangle ACM, let us see what is given. Okay, right? Check it, guys. So also, guys, see, this angle is equal to this angle, it's given, and this angle is equal to this angle, right? So what will happen? So I can say that since this is equal to this, then this is equal to this and this is equal to this, and these two are equal. So we can say that these two angles are equal, right? So it's very simple. So since angle B is equal to angle C, right, and this angle A, right, because see, yeah, we don't need this at all. Okay, so it becomes very simple. Since it's given that BM is equal to AM, that therefore angle B is equal to angle MAB, right? That means this angle should be equal to this angle. Similarly, since AN is equal to NC, so we can say angle C, that means this one, is equal to angle NAC, right? So, and since this angle is equal to this angle, so therefore we can say that angle MAB is equal to angle NAC. That means this angle is equal to this angle. Now from the congruency theorem, that means this angle is equal to this angle, this side is equal to this side, and this angle is equal to this angle. We can easily say that this triangle ABM is congruent to ACN, right? By angle side angle theorem, right? So this is very simple. So let's go to the next one, guys. Hope you got it. Okay. So this one. So in this types of question, they can give you a quadrilateral and there will be triangles inside, and they will try to ask you what is the relationship between the triangles. So for example, here it is given that this is an ABCD. That means ABCD is a square, right? And it is said that there are two lines. That means from vertex B we have a line BB dash, and from vertex C we have a line CC dash, such that these two lines are perpendicular to each other. That means this is 90 degree. Now they're asking, find out that this triangle ABB dash, that means this triangle, and BCC dash, that means this triangle, is congruent, right? So let's do it. So basically guys, here what is given in between these two triangles, do we have something? Yeah, one thing is there, that angle A. Okay, that means, or I can, let me write it completely, that is angle BAB dash is equal to angle CBC dash, right? And because both of them are equal to 90 degree, both of them are right angle triangle. Also we have one more thing, that is BC is equal to B. That means BC is equal to EB. So AB is equal to BC is also we can write, because this is a square, right? So if this is a square, the sides are equal. Now what? Now if we can prove that any other angle, right? So either this angle is equal to this or this angle is equal to this, we can prove that these two triangles are congruent. So this should be the approach. So first of all, you should write down what are the things given, and then you should look for the other thing which you can prove. So what we can prove here easily is that, let us say that this angle, let us try to find out or try to show that this angle is equal to this angle. Now how to show that? Now say in triangle, say this point is M. Okay, so let's say in triangle BMC, angle M is 90 degree. So therefore angle MBC plus angle BCM is equal to 90 degree. That means this angle plus this angle is equal to 90 degree. Now also we know that this is a square, so this will be 90 degree. Also we know that this angle C or this angle MBC plus, that means this angle plus this angle, right? So this angle can be written as ABB dash. That means angle ABB dash is equal to 90 degree. Now from here, if we compare or if we cancel out, right, that means say this is equation 1 and this is equation 2, and if we cancel this out, so this will get cancelled, this will get cancelled, and we can write that angle BCM is equal to angle ABB dash. Okay, and you see guys, BCM can also be written as BCC dash. So we can say that BCC dash is equal to angle ABB dash. That's it. So now if we write here BCC dash is equal to angle ABB dash, so by angle, side angle, we can say that these two triangles are congruent. So by angle, side angle. So that's it guys. So these types of problems, you just have to look how to apply these theorems, right? So these are simple problems where you don't need constructions. Now let us go to some other types of questions where you need some constructions, right? And then you can use these theorems. So for example, in this question, ABC is a right angle triangle where angle B is 90 degree, and it is said that D is the midpoint of this hypotenuse AC, right? So they are asking to prove that BD is equal to half of this, right? So what is given guys? So given is angle B is 90 degree and D is the midpoint of AC. That means I can say that AD plus DC, or in other words I can say directly equal, right? AD is equal to DC is equal to half of AC. I can say that, right? Now I need to prove that BD is also equal to half of AC. That means if I can prove that this BD is equal to this, then my job is done, right? So how do I prove that this side is equal to this side? Now take some time, think about it, right? And then I will solve it. Okay, let me know if you need some hint. So first of all, the hint is you need some construction, some kind of construction. It's up to you what type of construction you do. And guys, there is no hard and fast rule that there will be only one solution or one construction that can be done. A same question can be solved in 2-3 different ways. Okay. So for example, here, let me show it to you. Let me give one more hint. So we can do a construction such that from this point, we will draw a line, okay, say DE, okay. So, and such that this line is perpendicular, okay. So will it help us? Just see. So this is just a hint that these types of construction you can take. Okay. Okay, so let us say that we do a construction such that DE is perpendicular to EB, right? In that case, what happens? You see, this is also 90 degree, okay? So if you see properly, this ED can be showed to be parallel to BC, right? That means since angle AED is equal to angle EBC and both are equal to 90 degree, so I can say that these are corresponding angles, right? When AB is the transversal, right? So from here I can say therefore ED is parallel to BC, right? As these two are corresponding angles. So now what? So now we can use the theorems of corresponding angles. So since this is proved, now what we can say? Now we can say that if DB is the transversal, that means this is the transversal. If this is the transversal, this angle will be equal to this angle. That means angle EDB is equal to angle DBC. And let us say this is X. So say this angle is X and this angle is also X, some value X. Okay. Similarly, what can we do? What else can we do? Now see guys, in this we can say this angle is Y. Okay. This angle is Y. Right? What else we can do? See here. Okay, you need one more hint now. Okay, but let me see if you can do it from here. Okay. Okay guys, see here. Now I'll give you the hint. Now you see in these two triangles, we can say that this angle is equal to this angle. Okay, let me draw it in a new one. Okay, so it's something like this. Okay, and I have a line which is in this way, and I also know, guys, that this is the midpoint, right? So just let me see the naming: A, B, C. So this is A, and this is B, and this is C, and this is E. Just E. Okay, now you see, guys, in triangle AED and triangle ABC, what are the things common? See, this angle is equal to this angle, and this angle is also equal to this angle, because these two lines are parallel, and if AC is the transversal, then this angle will be equal to this angle, corresponding angles, right? And this is the common angle. So that means all the angles, that means angle A here is equal to angle A, that is common, and angle E here is equal to angle B, and angle D is equal to angle C. That means I can say that all the angles of these three triangles are equal. So these three triangles are similar, right? So these are similar triangles, and the property of similar triangle is the sides are always in ratio. That means here, if you take this side of the smaller triangle, that means if I say AD by AC, that means this side by this side, this should be equal to the ratio of this side, that is AE by EB, right? Or AC is 2 times of AD. So we'll put the value here. So that means this becomes half here, and this becomes AE is equal to EB is equal to this angle. This side is equal to this side. And what else? And what else? Now, if we can prove that this angle is equal to this angle, or this angle is equal to this angle, then our job is done, right? So now, by using say this angle, okay, so that means this is a right angle triangle, so this plus this is 90 degree, right? Similarly, this plus this is 90 degree. So try to find some common thing between them. Just try to do that. Done? So here we can show that this angle, okay, is equal to this angle, or we can say that this side is common. In that way also you can do. See, it's very simple. In triangle AED, okay, and triangle BED, what we can say that in this triangle, that means this triangle, okay, and this triangle, I'm just breaking these two triangles. I can say this angle is equal to this angle. That means angle AED is equal to angle BED. What else? This side I have already proved is equal to this side. That means AE is equal to BE, and I can easily say that this is the common side. That means ED is common. So I can easily say that by side angle side theorem, I can say these two triangles are congruent, that therefore I can prove that triangle AED is congruent to triangle BED. Now if these two triangles are congruent, I can easily show that this angle is equal to this angle. And if I can show that this angle, that means I have already showed it, right? That means angle DAE is equal to angle DBE. That means what? That means if this angle is equal to this angle, that means in the triangle DAB, that means in this full triangle, if this angle is equal to this angle, that means this side is equal to this side. Therefore, I can write that DA is equal to DB. Right? Now, if DA is equal to DB, my job is done. Why? Because that is what I needed to prove. Right? So that means BD, or in other words, I can say BD. That means DB or BD, same thing. BD is equal to AD, and I know that AD is equal to half of AC. That means this is equal to half of AC. So this is proved. Okay. Right. Okay, guys. So now, hope you like this problem. So let's go to the next one. So in the next problem, it is said that we have two triangles ABC and DBC. Right? These are two triangles with the same base BC. So say I have a triangle ABC and I have one more triangle with the same base. Okay, let me draw it in a different way so that it doesn't look same. So say I have a triangle something like this. Okay, something like this. So now it is said that AB is equal to AC. Okay, this is said that this is equal to this side. And it is also said that DB is equal to DC. Okay, so this point and this point D is the opposite of A. So in that case, I have to say that this is an isosceles triangle, right? So if this is an isosceles triangle, I have to draw this triangle as if this is an isosceles triangle. I cannot draw any triangle, right? So let me try to draw a isosceles triangle here. So, okay. So now what? Now say this is D, right? And this side is equal to this side. Now what are they asking? They're saying that if I join AD, let me try to join AD. Okay, if I join AD, then AD is a perpendicular to BC. That means I need to find out, or I need to say that to prove angle A, say this is E. Okay, so I need to say that angle AEC is 90 degree. If I can find out that this angle is 90 degree, that means I can say that this is perpendicular. Now how do we do it? Okay, so take your time, try to solve it. This is pretty simple actually. So let me just show this to you. The approach is that now how do you find this angle as 90 degrees? So how should we think? So the best way to think is that if we can show that this triangle is congruent to this triangle, then we can prove that this angle is equal to this angle. Now we know that this is a straight line and these are linear pairs of angles, and if these two are equal, then each of them are 90 degree, right? So the only thing that we need to prove is, that means if to prove this, we need to prove that triangle ABE is congruent to triangle ACE. Now let us see what are the things or what are the facts that are given to us. So that means I am trying to go in the reverse way and trying to find out what are the things that I need to prove this. So I already have this side is equal to this side, and since this side is equal to this side, this angle is already equal to this angle, and this side is common. Now always remember that side angle is not a valid theorem. So what is valid is either I need side angle side, or I need angle side, or I need angle side. Any two angles and one side is okay, but any two sides and an angle is not sufficient. Okay, it's not sufficient. So let me go for angle side or angle side angle. So that means if I can say that this angle is equal to this angle, then my job is done. Okay, So angle side angle and angle side is also the same thing, because if I have two angles which are equal, then the third angle should be equal, right? So now let's see how to prove that this angle is equal to this angle. Now for that, I will just see what are the things that I have. I can say that in this bigger triangle, in triangle ABD and triangle ACD, what are the things that we have? We have AB is equal to AC, one side is done. Other is BD is equal to CD. So this side is equal to this side and this side is equal to this side. Now what is left? Okay, if I can show any of this angle, this one, not any of this angle, if I can show this angle between these two sides, that means this angle. So now angle ABD can be written as angle ABC plus angle DBC, and it's given that this side is equal to this side. So if this side is equal to this side, angle ABC is equal to angle ACB, right? So I can write this is ABC can be written as equal to ACB, plus angle DBC can be written as angle DCB, because this angle is also equal to this angle. So this can be written as DCB. Now angle ACB plus angle ACB plus angle DCB can be said to be equal to angle ACD. That means I have proved that angle ABD is equal to angle ACD. That means this complete angle is equal to this complete angle. That means these two triangles are congruent. So that means if these two triangles are congruent, then I can easily say that these two sides are equal, because therefore triangle ABD and triangle ACD are congruent, right? So these two are, it's better I write it here. So this is congruent, and now I can say that angle BAD is equal to angle CAD, because these are corresponding parts of corresponding angles. Now once I get this, so I can put it here that angle BAD, that means this small triangle, now ABE, right? And this small triangle ACE can be proved easily to be congruent, because this side is common, right, and equal, and this angle is equal to this angle is equal to this angle. So from there I can show that these two angles are equal, and sum of these two angles are 180. That means this angle should be 90. Okay, so this is simple one. Let's go to the next one. Okay, now I have few more problems with me. So these types of problems are basically from inequalities. Now this is a simple problem of inequality, but let me just show with this problem what are the properties of inequalities. For example, a question may come in this way, that O is a point within a triangle ABC. That means if I have a triangle, say ABC, okay, and O is any point in between them, and if I join this, say this is O and this, and okay, these 3 points, so this is say O and this is say A and B and C. So what are the things that I can say here? Now what are the inequalities that I know? So we know that if I have a triangle ABC, so I can always say that the sum of the length of two sides is always greater than the third side, right? This is the first inequality, right? That means, for example, AB plus AC is always greater than CB. In this way I can write the others also. For example, AC plus CB is greater than AB. In this way I can write all of them, 3 equations, right? And second property of inequality is, suppose, this is very important. Sometimes we'll be using this also. Suppose you see here. You see, it's easily seen that this side is the longest, and you see this angle is larger than this and this. It's easily visible to us, right? So you see that the largest angle is always opposite to this longest side. You can easily see it in right angle triangle also. See, in right angle triangle, this is 90 degree, right? And this angle cannot be 90 degree, it should be less than 90. It may be, at max, it may be 45, right? Both sides are equal. And then one side has to be less. That means if this angle increases or becomes more than 45, this side has to be less than 45, so that the sum of both of them are 90 degree, right? But none of this will be equal to 90 degree. That means this is the largest angle in a right angle triangle. Now you see the side which is opposite to this is the hypotenuse. Now this is also the longest side, right? So in this way I can say that, suppose this angle, say this is A and say this is B. So I can say that if angle A is greater than angle B, then the side opposite to this angle, for example, say the side opposite to this angle is CB, and the side which is opposite to this angle B is this side, which is AC. So I can easily say that CB is greater than AC because this is the hypotenuse. Also, guys, even if it's not the hypotenuse, if we have something like this, say we have something like this. Now you see it's easily visible to us that this angle is less and this angle is more. It's visible to us, right? And this is 90 degree. Leave this angle. This is 90. Say this is 30 and say this is 60, right? And say this is A, B and C. Now you see in this triangle, this B is 90. Now you see, I am saying that angle C is greater than angle A. That means the side opposite to this should also be longer. So what is the side which is opposite to this angle C? The side which is opposite to this angle C is AB. And what is the side which is opposite to angle 30 or angle A? That is this base BC, right? And it's easily visible to us that AB is always greater than BC. That means we can prove, or we can take it as a theorem, that if there is an angle in a triangle which is greater than any other angle of the same triangle, then the sides opposite to them can also be compared using that, right? So now let's just see first this one and then we'll go to the next questions. So it said that AB plus AC, that means AB plus AC is greater than OB plus OC. How do we do it? So to do it, guys, you need a little construction, okay? And the construction is, suppose we extend this to this point, okay? For now, let's say we don't need this, okay? Fine. Now say this point is O and say this point is D. Okay, so I have constructed a line D. So now if we see here in this triangle, what can we say in this triangle? Okay, I'm trying to prove the first one. Okay, so this is a hint, try to prove it. Okay, see here, so we can easily say that this side is greater than, or this side plus this side is greater than this side, right? So what I can say is CB, okay, is greater than, this side is greater than CD in the triangle plus DB in the triangle CDB, right? Similarly, we can say in this triangle, this side is greater than, or this side plus this side is greater than this one, right? Okay, and in this small triangle also you can take, in this small triangle, what will happen in this small triangle? OB, right, can be said is less than DB plus OD. Okay. So using this, you can easily solve it. Okay. So similarly, if you can prove that this AB plus AC is greater than OB plus OC, then we can easily show that this AO plus OC is greater than, or AB plus CB is greater than OC plus OA. Similarly, if we add all of them, we can prove these two also easily. Okay, so try this at home. Since we have less time, we are almost done. So let me go to the next problems. So let's say this one. Okay, I have few more problems with me. So let me discuss this one. This is more important. Say, prove that sum of any two sides of a triangle is greater than twice the median drawn to the third side. Okay, that means if I have a triangle, okay, or let me not take a isosceles triangle, let me draw a triangle which is somewhat scalene. Okay, so this is a triangle. Okay, and this is a scalene triangle. Now it is said that sum of any two sides, say this is A, this is B, and this is C. So it's twice the median. So let me draw the median also. So say this is the median. So say this is D. Okay. So what are they trying to prove is that AB, okay, plus AC is greater than twice the median, that is AD. Okay. So how to do this? Think about it. So in these types of problem, these are inequalities problem, and the hint is you directly cannot prove this, right? So you need some kind of construction here. Now what construction will you take, okay, so that you can prove this? So and now let us say this is to prove. Okay, now what is given here? Given is this is the median, that means BD is equal to DC. This is given, right? Now how will you do solution? What will be the solution? Think about it. Or what type of construction will you take here? Okay, so let me give you the hint. The construction should be such, say I take a length, this DE, say this DE, okay, is such that it is equal to AD. That means I take a construction, okay, and this construction is such that AD is extended to point E such that AD is equal to DE. Okay, and this is a straight line. Now what? Now let me connect B and E. So if I connect B and E, now what? Now what? Now in this triangle, say in triangle BDE and triangle ADC, let's see what is happening. So since these two are straight lines, I can say this angle is equal to this angle because this is vertically opposite angle, right? So that means angle D is equal to angle, or both of them are D. So let me write down BDE is equal to ADC. Okay, what else? I have this side is equal to this side and this side equal to this side, right? These are given. right? And since AD is equal to DE, right? AD is equal to DE, and or let me write AD is equal to ED. That is better. AD is equal to ED. So AD is equal to ED, and BC is equal to CD, right? BC is equal to CD. So this we can say that, therefore we can say that this triangle BDE is congruent to the triangle CDA, right? Can you say this? So AD is equal to ED, AD is equal to ED, and BC, okay, this should not be C, this should be D, right? So BD, so BD is equal to CD, yeah, we can say this, and D is equal to this angle D, BD is equal to, okay, so these two triangles are congruent. So if these two triangles are congruent, so we can easily now show that this side is equal to this side, right? So now what can we what can we do here, right? So say this we have already done. So now we can say that AC is equal to BE. Okay, this side is equal to this side. Now what? Now in this big triangle, what can we say? In triangle AEB, okay, this bigger one, we can say that AB plus BE is greater than AE. We have just learnt it that this sum of two sides is greater than the third side, right? So now AB can be written as AB and BE can be written as AC because we have just proved it, right? That means BE is equal to AC, so we can write this as AC and AE. Now we know that AD is equal to DE. That means what? That means AE is 2 times of AD. So we can write this as twice AD, right? So just we have proved this. That's it. Okay. So similarly, guys, we have more questions, right? And we are almost done with time. So just guys take this question, or okay, let me just give you a hint in this question. So it is said that this is a triangle ABC and AB is equal to AC and D is a point on this. So prove that AD is greater than AC. So that you need to prove that this AD is greater than this length. So how do you do this? So in this one, I will quickly say that we have to use the concept that we have learned that if angles are greater, right, in a triangle, if one angle is greater than the other angle, then the side opposite to the greater angle will be longer. So let me prove this. So see here, in this triangle, this is the exterior angle, right? And exterior angle is equal to sum of these two angles. Now, so I can say that angle ACD is equal to angle ABC plus angle ACB, right? And I can easily say that ACD is greater than angle, this should be BAC, right? This should be angle because this angle plus this angle. Okay. Anyway, now if I ignore this angle, so I can easily say that this angle ACD is greater than this, right? So this is by logic, we can say that this is ABC, right? And also from here I can say that this angle is equal to this angle. We already know it, right? Because AB is equal to AC. So I can write that ACD is greater than angle ACB. Now you see here, this angle, what is the side which is opposite to this angle? The side which is opposite to this angle is AB. And what is the side which is opposite to this angle? in this triangle. So this is AD. So from here I can say that AD is greater than AB, and I know that AB is equal to AC. So from here I can say AD is greater than AC. So this is how you can prove this. So guys, there are lots of problems in this way, and hope you like this. You have liked this session, and this is also one more question. You can try to solve this and take this as an assignment. Okay, so and we have a course which is designed for you, and the link of the course is https, okay, and then vdnt.in/m triangle. Okay, if you write this link here, and you can just click it or search this link, you will get this page, okay, where you can register for this course. Okay, so guys, this course fees of this is 1999 or 2000 rupees, but you see, today there is an offer, right? Only today, that is there is a lightning offer, which this course is given at around 700 rupees, that is 699. And I also will tell you that this course will be of 7 sessions and approximately 9 hours. And you see guys, if you can do this much, whatever we have done in 1 hour, so in 9 hours, and you can completely master the triangles, right? So hope to see you in my sessions. So hope you enjoyed this live session of triangles. So and see you soon guys. Bye bye. Okay, see you soon. Bye bye.